this example, I want to take a look at how to simplify a natural logarithmic expression using the properties of logarithms that we've already talked about in other lessons. Again, the natural logarithm is just a logarithm of a specific base, of base e. So any of the other properties that we've talked about for logarithms in general of any base are going to apply to the natural logarithm, even though it doesn't look quite the same as the rest of them. It doesn't have log and then a base. You see this ln, that is your indication that you're dealing with natural logarithms. If you say to yourself, that's weird, you're saying natural logarithm, but I'm seeing ln. Why wouldn't they call it the logarithm natural, or why wouldn't they use nl? Well, you got to think back that in a lot of other languages, in English we'll put the adjective before the noun, like we'll say a green book, whereas in other languages they would identify the object as the book and then put the descriptor after that, as like a book green, like that in many other languages. So it's the logarithm. What kind of logarithm is it? It's the natural logarithm. That would be the reason for the ln instead of the nl. Don't let that confuse you. It's not an in. A lot of times students, I hear students say in. No, it's not in. It's natural log with that. So anyway, now that I've ranted about that, how can we simplify this expression into a single logarithm? Well, the first thing I want to do is I want to take advantage of my power property of logarithms. I see out in front of the logarithm, I see a number connected by multiplication. So I'm going to go ahead and rewrite that as the natural log of 15 squared, moving that number out in front back up into the exponent, minus natural log of 75, like that. Now I see some subtraction. So I can use that quotient property of logarithms. It says if I see the subtraction of two logarithms with the same base, I can actually put that back together as the quotient, as the logarithm of the quotient of those two things. So this would then become the natural logarithm of 15 squared over 75, like that. So I have gone and written this as a single logarithm now. Now, if I wanted to simplify that a little bit more, 15 squared is actually 225. And 225 divided by 75 is actually 3. So this actually simplified all the way down to just the natural log of 3, which is a much simpler expression than 2 natural log of 15 minus the natural log of 75. So just taking advantage of a few properties that we've talked about for other base logarithms already. If I wanted to do one that had variables in it, just to illustrate something maybe that had the use of all 3 properties, like let's say I had natural log of x plus 3 natural log of y minus the natural log of 5, like that. First thing I would take a look at here, I see an opportunity here to use my power property of logarithms. So I will rewrite this as the natural log of x plus the natural log of y cubed minus the natural log of 5. Then I see some logarithms joined by addition right here, so I'll go ahead and use my product property of logarithms to write this as the natural log of xy cubed minus the natural log of 5. And then finally, I can use my quotient property of logarithms like I just talked about a second ago. I have natural log of something minus natural log of something else. I can put that back together as the natural log of that quotient. So I do natural log of xy cubed over 5. And I've simplified that into a single logarithm, which is a much simpler looking expression than these 3 separate pieces being added and subtracted at the top. So again, just a mixed review of the properties of logarithms applied to a logarithm of a very specific base e.